we are going to talk about testing and analyzing a 5G network. Let's take a look at what is 5G and why do we need it. 5G is an amalgamation of various technologies that have come together for the very first time. New spectrum and bandwidth optimization is one major contributing technology. New spectrums are being introduced and they are being utilized in a more efficient manner by using multiple input, multiple output that allows us to put a number of different users using new modulation technique. Another new big thing in 5G is split RAN or open RAN technology. Till now, different industries have been using mobile technology uniformly, where the traffic goes through the same path, irrespective of whether they require high bandwidth, low bandwidth, or high response or low response. However, things are different in 5G. In 5G, we are seeing that network is being sliced to treat these different types of traffic differently and more efficiently so that we can address these types of traffic and process them with different logic across the network. Network function virtualization is also coming into the picture, along with network orchestration using the concept of lean design in 5G architecture. Multi-access edge computing is also an important factor in 5G, where we are talking about taking the entire hardware resource and the compute logic with the help of virtualization of hardware and software and pushing it close to the edge for better user experience. 5G is opening a window to onboard different vendors and integrating them under a single roof and evolving into a very cost-effective solution so that the enterprises can embrace it. Now let's talk about the new radio architecture with split RAN or open RAN. Till now, the radio access network has been coming as a single vendor solution. In 5G world, with the disaggregated radio network and decision logic in the RAN, multiple different vendors can come together to build the radio network. With separated out distributed unit and centralized unit, the mid-haul concept has been introduced for the first time. Service management and orchestration at this layer enables interoperability between different radio units. Measuring latency between these components and compliance to security is also a big element in this for Open RAN. 5G enables us to take advantage of 3GPP defined security procedures and methods and uniformly apply it across different elements of the network. Hence, it is important to identify the security loopholes at the pre-deployment stage for this new split multi-vendor architecture. The next element we are going to cover is disaggregation and virtualization. Disaggregation and virtualization has been around for some time now, but this is for the very first time we are seeing it most efficiently applied into the mobile network. In 5G, the network elements have been split into various different network functions for the very first time, like authentication function, session management function, access mobility functions, and policy decisions, etc. All these functionalities are being implemented as separate microservices that can be scaled, managed, and deployed dynamically. Thus, we are having a cost-effective approach both in the core as well as at the edge. Having all these technologies together for the first time demands thorough testing, analysis to ensure the reliability of the entire 5G network. To do that, we need to onboard an automated mechanism of test assurance. Such a solution should be able to automatically deploy the NMs, run different use cases, validate them, monitor them, and operate them, and all with zero touch. If we compare the 4G and 5G architecture, we can see that in 5G we have moved from a centralized monolithic architecture to polylithic distributed environment. Hence, validation of each element in the network, both for control plane and user plane, is a must-have in 5G testing strategy. In 5G, we have different servers and hardware covering the radio and core network for different network functions. All of them needs to be validated considering various types of scalable deployments. 5G comes with diversified use cases that makes the testing more challenging because while doing the testing, the test suite needs to create large number of use cases covering MBB, URLLC and MIOT applications. All this needs to be done constantly in an automated manner to verify these different use cases rapidly. The test result need to be captured, analyzed and decision needs to be made based upon that. One should also able to identify and mitigate the integration challenges. Various different test tools need to work seamlessly to validate different aspects of the entire 5G network. Hence, having third-party API support both for REST or SOAP is extremely important for integrating different tools to provide a comprehensive test automation solution. In 5G, considering the complexity of the use cases, it takes a long time to develop a new test case. This involves developing the test scripts, get the testers to testers, DevOps person to integrate it, and finally domain experts analyze the results. All this makes testing 5G very difficult. So what we really need is an easy mechanism to develop these test cases which can be easily modifiable, easily understandable and can be mapped to technical specifications. We also need to onboard an automated mechanism to analyze the test results and KPIs generated from different network elements, infrastructure elements and hardware components. So how do we do that? Here comes analytics and machine learning. We need to onboard a testing mechanism where we can ingest all this data, then correlate them using artificial intelligence and finally try to generate the root cause analysis. The in-depth analysis of all the logs and traces that are being generated by different network functions from the different parts of the network is very important. Considering the different virtualized layers, correlating them and an ability to create a dashboard that helps the users to determine if the network is operating properly or not is essential. One should be able to determine whether there is a need to scale, bringing different network components, add to the existing network functions, etc. should be understood from the dashboard inputs. Automated analysis of the reason for failures of the test cases is very critical. We need to understand, is this a test case authoring error or something to do with the configuration, or is it happening due to the application error? All of this analysis need to be made automatically. We need to able to come up with a build by build analysis as well whenever we are onboarding software releases from different vendors. This will help us to come up with a particular release combination that would be most stable for the deployment. At Rebaca Technologies, we have developed a cloud-native 4G, 5G and ORAN tester and analyzer called Abbott. It is deployed and being used in the market by many OEMs, SIs, and universities. ABOT has extensive support for all the different types of 4G, 5G NFs. ABOT emulated stacks are very lightweight, so they can be deployed in a MEC architecture as well. It has a plethora of plug-and-play test cases. ABOT supports different types of application traffic simulation, which can simulate traffic on a live network in a synthetic manner and capture different statistics. These test cases are written in English-like DSL language following the BDD framework and very easy to understand, modify, deploy, and verify. ABOT has an artificial intelligence driven smart editor, which even helps one write new test cases seamlessly using just the domain knowledge. ABOT having extensive REST API support makes it very easily integrable to any CI engine. That makes it easy to adopt to an existing automation environment as well. ABOT provides different insights on 5G network using any 3GPP compliant logs and packet traces. It analyzes them using AI technologies and put them in a ladder diagram for easy understanding and failure analysis. ABOT generates a dashboard with all the required information so one can understand the quality of the procedure, mobility statistics, infrastructure uses, etc. ABOT also gives a storyboard view of the entire test execution and the 3GPP procedure in English, so even a layman can understand what's being tested and what is the outcome. ABOT can measure the stability of the entire network and certify the reliability of it. It can track the system, infrastructure, and mobility related KPIs and correlate them all together. These KPIs are configurable, customizable, and one can apply new logic around it. To learn more on 5G and ABOT, visit us at www.rebaca.com. Thank you.